This video covers the review for section 12.11.2, exponential functions. Use point plotting to graph f of x equals 2 to the x minus 2. First number I start with is 2, because 2 to the 2 minus 2 is 2 to the 0, which is 1. So at 2, we are at 1. And then I do 3. 2 to the 3 minus 2 is 2 to the first, which is 2. So 3, we're at 2. And then I do 4, and 2 to the 4 minus 2 is 2 to the 2, which is 4. And then 5. 2 to the 5 minus 2 is 2 cubed, or 8. It's about as far as I can go there. And then we go 1. 2 to the 1 minus 2 is 2 to the negative 1, which is 1/2. Zero. 2 to the 0 minus 2 is 2 to the negative 2, which is 1/4. And negative 1, 2 to the negative 1 minus 2 is 2 to the negative 3, or 1/8. All right, we have a good idea about this graph now. It's doubling each time it goes up and halving each time it goes down. So all of these are 1/2 of what we had before it. So the graph doesn't touch the x-axis, but tries to get as close as it can to it. As you see, we can plug in any number for x and get a y value, and that's what says the domain is all real numbers. Or you can write it in interval notation, negative infinity to positive infinity. The range, this graph does not touch the x-axis, so the y values have to always be greater than 0. Or you can write that in interval notation, 0 to positive infinity. And we don't typically put the positive on there. If we graph 2 to the x plus 1, we do the same sort of thing. I like to find that x value that gives me 1 for my exponential portion, and so that's 2 to the 0, and the plus 1 is on the outside, so that's 1 plus 1, which is 2. If I plug in 1, that's 2 to the first plus 1, which is 2 plus 1, which is 3. If I plug in 2, that's 2 squared is 4, plus 1 is 5. And 3, that's 2 cubed is 8, plus 1, which is 9. And then on the other side, negative 1, that's 2 to the negative 1 plus 1, or 1/2 plus 1, which is 1.5. If I plug in negative 2, that's 2 to the negative 2, which is 1/4 plus 1, which is 1.25. Negative 3 is 2 to the negative 3 plus 1, which is 1/8, plus 1, which is 1 1/8. And so we see this graph is coming down and trying to touch the line y equal 1. And then the exponential growth is on the other side. And so this time it doesn't touch the line y equals 1. We can plug in any x value and get a graph, and that says that the domain is all real numbers. The range this time, this graph does not go below y equal to 1, and it doesn't touch y equal 1. So the range is everything greater than 1, or we say 1 to positive infinity. Either of those answers is fine. Number 8, solving exponential equations in which the bases are the same. These all have the bases the same. 2 to the x equals 128. 128 is 2 times 2 times 2 times 2 times 2 times 2. That's 16, 32, 64, and 128. That's 2 to the 7th. When we have the same base on both sides, we just take and drop them, and we get x equals 7. Letter B, these bases are the same. 2 to the x minus 4 equals 2 to the 5th. We drop the bases. We have x minus 4 equals 5. Add 4 to both sides, and we have x equals 9. Letter C, we have 2 to the x squared. The denominator is 2 to the 3x. The right side is 2 to the 4th. 2 to the x squared over 2 to the 3x, we use properties of exponents that say x to the a over x to the b is x to the a minus b. So we get 2 to the x squared minus 3x equals 2 to the 4th. So we drop our bases, and we have x squared minus 3x equals 4. We solve that one by subtracting 4 from both sides. And so we factor that as x minus 4 and x plus 1. We solve that quadratic equation by setting our factors equal to 0. Then we get x equals 4, or x equals negative 1. Letter D, 27 and 81 are both base 3. So this is 3 cubed, so 3 to the 3x, and 81 is 3 to the 4th power. So we drop those bases, and we get 3x equals 4, or x is equal to 4/3. Letter E has e to the 5x squared equals e to the x times e to the 4x. E is our natural base. The right side, when you have a like base and you multiply, you add your exponents. And so x plus 4x is 5x. When we have the like base, we drop it off, and we just say that 5x squared equals 5x. That's our quadratic equation. We get 0 on one side, and we factor. We factor out the 5x, and we're left with x minus 1. So we have 5x equals 0, or x minus 1 equals 0. If 5x equals 0, that says x is equal to 0. And if x minus 1 is equal to 0, it says x is equal to 1. Letter F, 100 is a base 10, 10 squared. 0.001 is 1,000th, or 10 to the negative 3. We equate the exponents. 2x is negative 3. Gives me x is equal to negative 3 over 2. This concludes the video for section 11.2, exponential functions.